Assalamualaikum warahmatullahi wabarakatuh. So my name is Haziq Faizuddin bin Muhammad Yazid, and I will tell you about the introduction. So the most simple definition is if A and B are two logical expressions, and if A implies B is tautology, we can say that A logically implies B. So now we will move on to truth table. So on the left side, you can see an example of truth table. So truth table are used to prove a logical implication expression. If all conclusions are true, then it's a tautology statement.
Hi, Assalamualaikum. My name is Ahmad Mikael Koim bin Ahmad Rashidi. I'm a mat222 student from class D1 CDCS 1114B, and I will be explaining about another example of truth table when the statement is a contingency statement. The statement will be a contingency statement when there are at least one false value in the conclusion.
Assalamualaikum, my name is Mahdi Munasri and I am from D1 CDCS 1114B. My student ID is 2022477362. So, if the conclusion from the truth tables are all false values, the expression is a contradiction statement. So for the first questions, we must construct a truth table to determine whether open bracket negation P or Q close brackets and open bracket P and open bracket P and Q logically implies to P and Q. Before we make a truth table, we must divide all of the operations so it will be easier for us to decide the values of the statements. As you guys can see as the table shown below, I divided the equations one by one, so it is easy for me to decide the values of the statement. So for the first one is P, which the values are true, false, false. Q, true, false. Negation P, false, true. Negation P or Q, true, false, true. P and Q, true, false. P and open bracket P and Q, true, false. Negation P or Q, close brackets, and open bracket P and open bracket P and Q, close brackets, true, false. For the last one is A implies to B, which is A is actually the negation P or Q, close brackets, and P and P and Q, and B is P and Q. All of the values that we get from A implies to B are all true. Since the statement is tautology, since all true values are true, therefore negation P or Q and open bracket P and open bracket P and Q close brackets implies to P and Q, and the arguments are valid.
So moving on to the next question number 2. The question says that construct a truth table to determine whether bracket P implies Q bracket and bracket nego P or Q bracket logically implies to nego P. So let's briefly go through for the first rule. When P is true and Q is true, P implies Q will be true. And when P is true and Q is true, nego P or Q will also be true. So for the statement, when P implies to Q and nego P or Q, if P implies to Q are true and nego P or Q is also true, the statement will also be true. So next we will check whether this statement is implies to nego P. So when bracket P implies Q bracket and bracket nego P or Q close bracket is true, implies to nego P, which is nego P will be false. The implication will be false. The conclusion will be false. So next, for the second row, when the statement bracket P implies Q close bracket and bracket nego P or Q close bracket is false, implies to nego P, which is false, the conclusion will be false. And for the third row, where our P is false, so the nego P will be true, and the true value for the statement bracket P implies Q close bracket and bracket open P or Q close bracket is true. True implies to true, the conclusion will be true. And for the last row, our P is a false value, so the nego P will be true. So for the value for the statement nego P implies Q close bracket and bracket nego P or Q bracket, true implies to true, the conclusion will also be true. So the conclusion for this question is, the statement is a contingency statement because there are a false value. Therefore, bracket P implies Q and bracket nego P or Q close bracket does not implies to nego P.
So moving on to the last question, which is question 3. Construct truth table to determine whether in bracket A implies to B and negation of B implication to negation of A. So the truth table will be A, B, negation of A, negation of B, A implies to B, in bracket A implies to B, and negation of B. And the last one is in bracket A implies to B, and negation of B implies to negation of A. So the truth table for A will be true, true, false, and false. And for B, it will be true, false, true, and false. For negation of A, it will be false, false, true, and true. For negation B, it will be false, true, false, and true. So moving on to the next one, which is A implies to B, it will be true, false, true, and true. And then the next one, which is in bracket A implies to B and negation of B, it will be false, 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 and true. So the last one, which is in bracket A implies to B and negation of B implies to negation of A, it will be true, 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 and true. So based on the truth table, we can make a conclusion, which is the statement is a tautology since all the truth values are true. Therefore, A implies to B and negation of B implication to negative A and implication to the negation of A and the argument are valid.
So at the end of our presentation, we have come to a conclusion, which is, if a statement is a tautology statement, it is proven that it will be logically implies. And if the statement is not tautology, which is contradiction and contingency, it is proven that it is not logically implies. And in logically implication, truth tables are used to prove whether a statement is tautology or not. So that's all from us. Thanks for watching. Thank you.